Okay, everything started. And today is our first lecture on C. All right, so basically the rest of the course, we're going to be programming in C. And we're going to be making relatively small programs that you'll use in a Linux environment. So basically, we're going to be making programs that correspond to commands that you can run from your bash from a bash terminal, or inside a bash shell, I guess more correctly. Okay, so what exactly is C? Now C is, I guess is it the most wide? So it's certainly the most widely used of the older programming languages. It's a general purpose compiled procedural computer language, right? So general purpose means you can use it for pretty much any purpose. So it's not specifically targeted at any domain. It's compiled. Now in 121, 121 too. In CISC 121 and CISC 124, we more or less hide the compilation process from you. So you're often told that Python is a interpreted language. So in other words, it doesn't have a compiler. That's actually not true. So the Python interpreter actually does compile your Python program into what's called Python bytecode, and then it's the bytecode that's interpreted by the interpreter. Similarly with Java, your Java program is compiled by a program called the compiler, and then that bytecode is run on the Java virtual machine, right? But because of the way that Python works, and because of the way we teach Java using an IDE, you never explicitly compile a program. That's going to change in this course. So in C, you're going to have to explicitly compile your C programs before you can run them. And then furthermore, it's a procedural computer language, so not object-oriented. Although you can create an object-oriented C program. It's just you have to go out of your way to do so. So it's a structured programming language, which means it has things like loops and if statements. Now, the good news for this course, or for students in this course, is that you already know the core language because you've taken a Java course already. So the core language, loops, conditions, creating variables, you already know how to do all of that, right? C functions look a lot like Java methods. And the C language even has a main method, right? Just like, has a main function, just like Java has a main method. So the fact that you know C makes your life a lot easier in this course. Like Java, C has a static type system, which means the variables have types, right? And the compiler knows what those types are before it compiles your program. And it has recursion, which turns out to be useful. Sorry, hang on. I've got a couple of cats that are causing problems. Come on, you two. Come on, Ed. Come on. Come in. All right. Sorry about that. C is often referred to as a high-level language, but your opinion of that is going to change, I think, in this course. So Java and Python hide a lot of stuff from the programmer. Right? So Java and Python are considered high-level languages, but they're considered to be higher-level languages than C. So for example, to print something out, Python or Java, right? In Python, you just write print and then blah, and you don't care what blah is, right? The interpreter takes care of everything for you to print something out. In Java, you just write system.out.println and then blah, right? Where blah doesn't matter. Now in Java, when you make a class, you know that you can override toString to produce a string representation of an object. Right? And that's about as complicated as printing something out gets in Java. Printing something out in C turns out to be, you basically have to do everything to get something printed out. So there are functions that you print out primitive types, but as soon as you make some sort of, I guess, compound type, right? So something that would correspond to a Java object, right? You now have to do all the work yourself to generate, just to print out that thing, right? And there's no standard function that you would write to do the printing, right? So in Java, it's always toString, right? You just override toString. In C, you end up making a function that could be called whatever you want, right? So in C, it turns out a lot of the things that you would not have to do in a language like Python or Java, now suddenly it's you're responsible to take care of all this stuff. So C is often called high level. That's as close to the machine as possible while still being architecture independent, right? And so what that means is that in C, the programmer has control over over allocating memory, right? It's not just control. You are responsible for allocating memory, right? So if you want an array, you have to allocate memory for that array. You then have to fill in the values of that array. You have control over, you are able to access individual locations in memory. Right? So, so in Java, you know that objects are references. Right? You may have been told that references are actually the memory address of those objects. Right? In C, you've got these things called pointers that really are memory addresses, right? They really do point to the location of an object in memory. And then you can do things with the memory address, right? So you can go to that memory address and then you can go to the next location in memory. C even gives you the ability to interpret the bits in memory, right? So you can store an int somewhere, but then you can tell, then you are able to tell the language, or you're able to, as a programmer, you're able to reinterpret the bits of that number as something else. Right? And so that's what it means to be as close to the machine as possible. If you want to learn about the definitive history of C, you can hit that link. So that's a little, well, it's not that little. It's basically an article that was written that describes the history of the C programming, the history of the C programming language by the people who actually created the language. I'm going to talk a little bit about it, but all the details are here. So C basically came about roughly in the late 60s, early 70s. So as a programming language, it's now about 50 years old. One of the creators was this, what was he? He's just a computer programmer. He's an engineer. He was a bunch of things. It's this guy named Ken Thompson. And he wanted to create a comfortable computing environment constructed according to his own design using whatever means were available. Right? So in other words, he was like, you know, one of the original hackers. Right? He's got this computer. The funny thing is he has this computer. He doesn't even have any software. Right? So he had this computer called DEC. So DEC is the digital equipment company. I think that's what it is. I don't know if they're still around or not. When I was doing undergrad, they were still around, and the Queen's University undergraduate lab actually had a bunch of DEC computers. The computer he had was this thing called the PDP-7, which is sort of famous in the computing world. He had 8 kilobytes of memory. 8 kilobytes. That's 8,000 bits of memory. Right? Your cell phone probably has 4 or 8 gigabytes of memory. Right? A million times more memory than the computer he had. No software. All he's got is this giant box that represents a computer. Right? So basically, they have to write their own operating system. How do you write an operating system if you don't have a programming language? Well, you have to make a programming language. So that's what they went about doing. That's their computer that they were using. So that's the PDP-7. At that time, that's how much money it cost, 72,000 US dollars, which would be roughly the equivalent of 600,000 US dollars in 2020. Right, so these things were not cheap. Obviously, individuals would not buy them. Right, so these were things that companies would buy, and only a very small number of companies would buy these things. That's how you access the computer. That's a keyboard. Type things in to input stuff into the computer. Output, notice there's no monitor, that's a printer. So you would type something in, or you'd run some command, and then it would print literally to a printer, and you would see the output as on a piece of paper. Okay, so this computer, their effort started in 1969. Ken Thompson created what's called the B programming language. So that's the predecessor to C. If you wondered where plus plus and minus minus come from, that's where it comes from, all the way back in 1969. So they, using B, they actually wrote the first Unix kernel. Well, B and then C. So C evolved from B, then they wrote a Unix kernel. So this is when they created their own operating system. That's in 1972. And as they're writing the operating system, the C language is evolving. So as they're finding out what features they want to add to the language, as they're actually trying to use it to do something. And so finally, in 1973, that's basically the first version of C. That's basically when the first version of C was finalized. And then in 1978, they published this book right here, which you can still buy today, and is actually used in a lot of places that teach C for the first time. Somewhat surprisingly, that book is still used. And I don't know why, because it describes a very old version of the language, which is, I mean, the modern versions of C are quite different than the version of C that's described in that book. But a lot of places still use this book to teach C. Okay, now more modern versions of C. So eventually C was standardized. So the language was standardized by this organization called ANSI and the ISO in 1989. So the version of C that we use in this course is the 1999 version of C. So that's C99. Notice that the language doesn't change very rapidly, right? So the Java language changes every 6 months, right? Python gets an update every once in a while, right? It's the time between updates in C is very long, right? So that's the version we use. 2011 is the version of C that's used. Well, 2011 is actually the most recent version of C, because the 2017 version of C doesn't actually change anything. And there is a 2023 version of C that will eventually come out, I guess, next year. We're using this version of C. You're not missing out on any of the features from 2011. So where's C used? Most operating system kernels are written in C. So the Linux kernel is C. The Mac OS kernel is C. Every Unix kernel is C, pretty much. What's it called? Windows, that's the one. Windows is C and C++ and assembly. But that's because C++ is the language that's primarily used on Windows. C++ is another language called C#. Embedded systems usually use C. So any computer in what's usually a small device with no monitor, right? I guess that's a okay definition of an embedded system, right? So things like a clock, a router, all of the little computers that control all of the devices in your car in a modern automobile, those are all embedded systems. Most of those are programmed in C. Actually, they're not programmed in the full version of C. They're programmed in a subset of the C language. Most of the interpreted languages that you use are actually implemented in C. So Python, the standard implementation of Python is in C. Languages like Perl and Ruby and PHP, which doesn't matter if you've heard of these or not, these are all, the standard implementations are all C. Most Java virtual machines are written in C or C++. C is so prevalent, right? It's everywhere, that most modern programming languages can actually call C functions. So in Java and Python, there are ways to call functions that exist in C libraries. Hey, if you any very intensive computer graphics application, probably written in C or C++. So all of your AAA video games, probably C++, because most of them run on Windows. There will be a lot of C in there as well. Anything that's computationally intensive, a good chance it's written in C. Scientific applications are still written in Fortran as well. Fortran's even older than C. And there's a lot of other places where C is used. Historically, C has always been the #1 or 2 language on what's called the TIOB index. So this thing here, I actually have the web page here pulled up. Okay, so TIOB is it's basically it's an indicator of the popularity of a programming language. It's not the actual amount of code that's out there. Okay? So it doesn't measure how many people are working. It doesn't actually measure how much code is out there in any particular language. Right? It basically measures how much interest is there in the language based on things like Stack Overflow postings and internet searches. Right. So historically, C has always been 1 or 2. This month, it happens to be #2. Right. Python is currently #1, and Java is currently #3. Right. So these are always for the past, I don't know how many years now. These have always been 1, 2, and 3. Right, in some order, and the order changes every month. So, yeah. So I mean, don't be surprised if next month it's Java, right, or next month it's C or something like that. C++ is normally #4, and then it falls off pretty sharply after that point. Right? C# is popular because it's used a lot in Windows. Visual Basic is also popular because lots of non-programming people are able to program in Basic. Right? So lots of people who have office type jobs, for example, will work in Visual Basic. Okay, now we're going to be programming in C, so you need a C compiler. If you already installed Windows, if you already installed the Linux subsystem on Windows, you just have to install GCC. The instructions, just hit that link there. That'll take you to how to install GCC. It's pretty straight. It's easy on Windows. Mac, you just have to install Xcode, the command line tools for Xcode. So if you've already done this, you already have, you're all set to go. If you haven't done this, just open the terminal, type in that line. You'll be ready to go. Your Mac computer already comes with a compiler. It's not the same one that we use. That's not the same one that we'll be using in Linux, but it's close enough. It's fine. If you're remotely logging into, what's it called, CASLab, that's fine too. The CASLab's already got GCC installed. I guess after reading week, I assume CASLab will be opened again. You can just go there and work if you want to instead. You can, if you're on a Mac, you can install the full Xcode suite. I don't know if you want to do that. It installs a ton of stuff. It takes like 40 gigabytes of disk space. So I don't know if you want to do that. All you really need are the command line tools. You'll also want a C-aware text editor. So a C program is just plain text, right? Just like Python and Java. Visual Studio Code's probably the easiest one to use on all operating systems, right? So it's the simplest one to set up. You can get it to work, right? You can open up a console in Visual Studio. It runs everywhere. If you're on a Mac, there are lots of other text editors that you might want to consider. Most of them you have to buy, though, if you're on a Mac. I forget what the one that people really like on Mac is called. But anyway, Visual Studio Code works fine. You can, if you're on a Mac, so you can, in fact, install the C programming development tools in Eclipse. I don't know if so I'm not going to recommend this route. It will work. If you're on the Linux subsystem for Windows, that's not going to work if you're on Windows 10 because there's no graphical applications for the Linux subsystem in Windows 10. It might work in Windows 11. I haven't tried. All right, so you need a text editor. You need a compiler. So you'll have to get that set up soon. Well, certainly by after reading week anyway. Documentation. Every function that's part of the C standard library you can find on either of those two websites. It doesn't matter which one you want to use. They're both more or less the same. Well, they both more or less provide you the same information. You can find out other things too, like how to write loops and things about how to create variables, how to make arrays, and stuff like that. You can find from this website here. It's a little hard to find, but all of the library functions in the language, you can find documentation for them here. And of course, you can always do an internet search, right? If you don't want to read the documentation. The documentation is very, well, it's documentation, right? So it's not a tutorial. So it can be difficult to read, especially for new programmers. Fun stuff. So C is a very, what's the best way to put this? So when we're using C, all the examples that you'll see in the course, I mean, they're pretty much readable. You should be able to read all the examples, right? You may not know exactly what everything's doing at any given time, which is fine, right? But you'll be able to read it. So in other words, it looks like, sort of looks like English, right? Or it sort of looks like Java. So it looks like a programming language. Every year, there's a contest called the International Obfuscated C Contest, which has a website here. So basically, the point of this contest is to write a small C program that does something cool. And so, like by small, I mean small, like a few kilobits, a few kilobytes, right? So something that would fit on 1 or 2 pages of your editor. And they should, and it's supposed to do something interesting. It turns out that the language is defined in such a way that you can do very complicated stuff using a very small amount of code. So for example, this program here computes the value of pi. Okay. I can't read these programs. So, I mean, I teach this course, but I can't read a lot of these programs. This program here, right now, if you read this, it's very strange, right? Double LOP blah equals a bunch of weird stuff, right? This program here, I think for Windows, oh no, this is for, sorry, this is for Linux. This is all Linux stuff. Actually simulates a flight simulator. So its output is actually that thing there, which is kind of surprising. Found samples an ASCII image. What does this do? Do they actually have it? No, they don't have an interesting thing here, right? But it's possible to write very complicated programs in a small amount of space. And a lot of these programs aren't really readable, which is where the term obfuscated comes from, right? So the archive of all the contest winners are here. So if you have any free time and you're interested in what people are doing with the C programming language or all the cool things you can do with a very short C program, go ahead and hit up some of these links here. So what does a C program look like? Sort of looks like a Java program, to be honest. So you end up with these individual source code files, right? So just like Java, every class is in a .java file, right? What C calls a compilation unit is in a .c file. Right? Oops, sorry. It's just plain text, right? So it's just regular old plain text. You can edit it with any old text editor. Usually with a C program, so in any non-trivial C program, for every C file, there's another file called a header file, right? Not necessarily for every file, but for most files, there's also a header file, which is also plain text. Right? It's also written in C, right? So it's just the way that the program's organized, right? And so we'll explain what header files are used for a little bit later in the course. Now we'll make some simple C files. Every C program starts running at a function called main, just like Java, right? So to run a program, you need a main function. A main function has to be in one of your C files. Okay, so the simplest C file you can have, the simplest C program that you can make is just a C file that has a main function in it. For example, there's hello world. So we got a main function. It kind of looks like the Java one. And in fact, there is a version that's almost identical to the Java version, right? It's very close. It's quite the same, but it's very close. our main function, it returns an int. Right? Void means there's no parameters to the main function. Right? So this is one of the 2 or 3 legal forms of the main function in C. There's another form as well, but this is one of the two. That thing here inside double quotes, right? That's a C string literal, right? So similar to a Java literal, right? Something in double quotes is a C string literal. Now, fortunately, if you just have a literal or a string, there is an easy way to print out the string. You can use puts. Right? So there's a function called puts that you can use to print a string. It's defined, right? So that puts function is declared in a header file called standard.io.h. So that include statement up here, that's similar to a Java import statement, right? So in Java, you import the class that you want to use, right? In C, you include the header file of a, I guess you include a header file that includes the declaration of functions and variables that you want to use. Standard.io.h, that's the header file that defines all of the standard library input and output functions. Okay, if you hit up one of those, sorry, here. So if you click on one of these links here, and this takes you to the landing page for the C language, somewhere where the headers. Expressions, there's a link to the header file somewhere. Where'd it go? C, oh, here we go. No, C, here we go. Headers. So if you click on the headers link, it lists out all of the header files in the standard language. Right? There aren't that many of them. In Java, you have thousands, I think, of classes in the standard library. Python, you also have lots. I don't know how many. But there's a lot of different classes in the Python standard library. C, this is it. It all fits onto one web page. Standard IO is here, right? So these are all the functions that deal with input and output. And then you can see all the functions that are here. Okay, so you use puts to print a string. This thing's supposed to return an int. So in this case, we return 0. Now remember in Bash, when you run a command, every command has an exit status, right? So the exit status is 0 if the command runs without any errors, right? It's non-zero if the command runs, but there are some errors, right? Where does that return value come from? It comes from here, right? So our C program, when it returns a value from the main method, that value gets returned back to the operating system. And so it's the operating system that sets the exit value for the exit status for a command. Right. Now, if this return statement is not here in C, right, even though this says it returns an int, if you leave this line out, the value 0 gets returned. So in other words, the exit status for this program is also 0. So that line is technically optional for the main method. So somewhat surprisingly, it's optional for any function in C, which is also weird, but that's the way it works. So it'll return, if that line's not there, it returns 0 anyway. The same hello world program can be written like this. So printf is a function that we're going to be using a lot in this course. So printf is formatted print, right? There is a string that I want to print, right? So it's the second argument to this function, right? This %s means interpret whatever this is as a string. So this will print out the string representation of whatever that happens to be, right? /n or \n means new line, right? So print that out and then go to the next line, which in this particular case is equivalent to puts. Puts can only deal with strings, so you can only ever output a string literal. Here, printf, sorry, a string literal or a variable that is a C string. Printf can deal with strings and any other primitive type, right? And so we'll, or any of the built-in types. And so we'll talk about the built-in types a little bit later on. Okay, now there's your C program. So you've written your plain. Oh, let's write it. So let's do, or let's see what it looks like in our editor. All right, Shift Control here so you can see everything. So here's hello one, right? You can see it's just plain text, right? So it's just a file, ends in .c, right? There's hello two, again, just the file, ends in .c, sorry, .c, right? Now, this defines a C program, but to actually create the C program, I have to compile the code, which means I have to run a program that can read this code and produce an executable program. So for that, you need your console. Right, so let's just see if these files are here. Right, so they are in fact here. So there's hello 1C and there's hello 2C. So to compile the program, I need to use a program called a compiler. So our compiler in this course is GCC. On Mac, you can also use, on Mac it's also GCC. You can also use CC, I think, and everything should be fine. Okay, so let's go here. All right, so we're just gonna do it this way. So to compile our program, right, tell it which program you want to compile. Right, so you tell it which what the source code file is. -O, that's the name of the that's the name of the program that the compiler will produce. Right? So if I don't do anything, if I just type in that, right, you're going to see that there's a program somewhere called. Sorry, there's a lot of code in this particular directory. There's supposed to be one called, where'd it go? Something.out. Oh, there it is. Okay, so if you don't use -O, then the compiler spits out a program called a.out. Right. So if I run a.out, I should get hello world, and I do. Right. But normally you want to name your program something sensible. So I'm going to call the output program hello1. S -L. Okay, so you can see that the program hello1 has been created. Notice that the execute bit has, or the execute permission has been set for this particular file, for the output. Right. So what does that mean? It means you can run it. So how do I run it? .hello1. And there you go. You can do the same thing for program 2. Right. So I'm going to call that program hello2. Or I'm going to call the executable program hello2. Right. I'm going to compile the source code file hello2.c. So there's my program hello2. Again, notice that the execute permission has been set on that file. So we can run it. In other words, unlike a bash script, you don't have to go in and change you don't have to go in and set the execute permission yourself. Right? It produces an executable program automatically. Okay, so what does the compiler do? Well, a compiler actually, so in general, a compiler takes or translates code written in one language and it converts it to another language. So that's in general what the compilation process does. Now, when people talk about compiling C code, what they mean is you want to take your source code file, right? So I want to take this, I want to translate it into something that the computer can run directly, right? So the other language that it translates to is something called machine code, right? And a compiler is just a program that does this process. There is a fourth-year course where that's sometimes offered. I don't think it's offered every year, where you actually implement a compiler. There are many C compilers to choose from, so there's a lot. Well, there aren't a crazy number, I guess, but there are multiples that you can choose from. So in this course, you're probably using GCC if you're on Linux. If you're on Mac, even though you type in GCC, the compiler you're actually using is a combination of these two things here. So Mac uses technically the technically the compiler is LLVM. CLang is the front end to this compiler, right? So CLang is the C language part for that compiler. Okay, good. Now, so there are some bits and pieces in this program that will be a little bit unfamiliar to you, right? Anything that begins with the hashtag or the pound symbol in a C program, that's what's called a preprocessor directive. So hashtag or pound include is telling something called the preprocessor to do something. All right. So what is the preprocessor? So when you go to compile your code, the first thing, one of the first things that happens is that this thing called the preprocessor runs and looks at your code. Right? So when we compile this code, the preprocessor runs and it looks for things that start with a hashtag, right? And then it will do something with whatever follows the hashtag, right? So the include directive tells the preprocessor to take whatever is in this file, right? So whatever's in standard.io.h is just going to drop it in here. Right? So all of this gets replaced with whatever's in standard.io.h. Right. Inside standard.io.h, there's just a bunch of function declarations, right? So sort of like a Java interface, right? So remember Java interface, you get a bunch of methods, but the methods have no bodies, right? No implementation. Inside this header file, there's a bunch of functions with no bodies, right? So this is C's way of saying, hey, there's a function called printf, right? So this is defined, this is declared in this header file here, right? There's a function called printf. It doesn't say how the function is defined, right? It just says there's a function called printf. So inside, so after you include the file, you're allowed to use the function printf now, right? So this is sort of analogous to importing a Java class. Right, now remember what this does, takes the contents of standard.io.h and just drops it into here, right? That's literally what the preprocessor does, right? It literally replaces all of this with the contents of standard.io.h. Right. The preprocessor is, it can be a separate program, right, from the compiler, or it can be part of the compiler itself, right? It depends on the compiler implementation. The include directive tells the preprocessor to insert the contents of a file into a C source code file, right? And I need to do that because that's where puts and printf are declared, right? I can't use a function in C, or the C compiler cannot compile the program if it does not know that these functions exist, right? So somewhere you have to tell it these functions exist, what the signature, I guess, of the functions are, and so on and so forth. Right, so we have to include standard.io.h in order to use these two functions. What if our IDE can build, compile, and execute C? Do we need it? No. If you have an IDE that can do all this, then I'm not going to ask you how to do it. Right. So you're not going to get a midterm question from me or an exam. Sorry, you're not going to get an exam question from me that says how do you run the C compiler or how do you write a makefile. Although they have asked you that in the past, I'm not going to ask you that sort of thing. So if your IDE can do all this for you, great. Go ahead and use your IDE. Right. Comments. Comments in C are the same as comments in Java. Right. That's all I need to say about that. So, right here, that's the multi-line comment style. Right. So, for example, I can do something like this. Right. So this program prints this program, right? I can do something like that, just like you can do in Java, right? That's the end line. That's the line ending comment, right? So as soon as you see as soon as the compiler sees the double backslash, it knows that that's the end of the line, right? So your comment can go. It's a one-line comment that ends a line, right? So same as Java. Main function, every C program coded. Oh yeah. So C is a bit funny, right? Because it runs in a lot of places. So for our purposes, you know, when you compile the C program, you've always got a console, right? In other words, you've got somewhere to send the output of the program, right? That's not true of every computer system that C runs on, right? So so if you have a C program that's running on a computer in your car, right? And a computer in your car, it could just be a very tiny chip somewhere, right? So a single chip that say controls something in your car engine, right? Your modern car has got roughly 100 computers in it. So that doesn't, right? That thing's not printing anything out to a terminal, right? So anything that prints something out to a terminal like this, that's called a hosted execution environment, right? So anything that basically runs like this, right, in a console, it needs a main function. Right? The stuff in an embedded system does not necessarily need a main function, but that's, I mean, we don't care about that, right? So we need a main function somewhere. I guess that's all I need to say about that. Oh, here we go. There's two common allowable forms of C, right? So there's the first version that we used here, right? Second version here. This sort of looks like the Java version. Right? Sort of. It's not exactly the same, but it's sort of the same. I guess this part's the same, right? Wait. Yeah, it is the same. So that thing there, that's the number of input arguments. That's the number of command line arguments that are passed to the C program, right? So that's like getting the number of command line arguments from in Bash, right? Now arg count here. So this is arg count, right? Or arg C, number of command line arguments. This is always at least one. Because the name of the program counts as one of the command line arguments. This is always at least one. This thing here, which looks very strange at this point of time, I agree, right? The way you should read this right now is, so this is an array, right? So argv is an array. So that's what the square brackets mean. Right? That's an array. Star, that's C's way of saying string, right? So this thing here is an array of strings, right? So if so every command line argument is an element of that array there, right? The first element of this array is the name of the program. The second element of this array is the first command line argument, so on and so on and so forth. Okay. I guess I should change. Let me change one of these programs here. So let me change hello1 to show you what's going on. Int arg count. I'm sorry, car count car. Right. So let's not do anything with this yet. So let's save our program. Right. So remember when you're editing whenever you edit a program, right, you always save it before you compile it. Right. Otherwise, you end up compiling the old version of the program. Recompile my program. Now here's the other thing you have to get used to, right? Every time you make a change in C, you have to recompile. Okay, so you have to rebuild your program. Okay, that works great. So hello1 still runs, great. Right. Now let me print out the number of command line arguments. So I'm going to do. Don't worry if you don't understand what I'm about to do. Okay. So printf is the formatted print function, right? Also lives in this header file, right? It's also declared in that header file, right? Arg count, I know that's an int, right? So I want to tell printf to print out that value as an int. So %d or %i will tells printf to interpret this number here as an int, right? \n, new line. So recompile, right? If I call hello1 without any command line arguments, number of arguments is 1, right? A, B, C, it's now 2, right? The FG, it's now 3, right? If that's all a single string, right, that's going to be 1 again, or 2 again, sorry, right? So this is just like our bash. These are just like bash scripts, right? You can pass in command line arguments to your C program. These are the two common forms of main. Now, the language standard says that compiler implementers are allowed to put in their own versions of main, right? So whoever wrote the GCC program is allowed to include their own custom versions of main, right? Microsoft, for their Visual Studio Visual Studio compiler, they can put in their own versions of main, right? The CLang people can put in their own versions of main. So if you want to use a different version of main, you have to look up the documentation for your compiler. All right, so there's a function declaration in C. That's a function definition in C. Right. That's the return type. There's no access modifiers in C, right? So there's no public, private, blah, 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 right? It's just the return type. Name of the function, arguments to the parameters of the function. In C99, if your function has no parameters, that has to be void, right? So in other words, you're not allowed to write just empty bracket in C99 or above. I think C99 above anyway. Older versions of C, you could just write main empty bracket. Puts. Okay, so puts is the way you can print a string in C. It automatically includes a new line at the end of the string. And that's formatted print. So I've already told you, I've already sort of described what that does. And then finally, there's a return value. Inside the main method, that sets the exit status of the program. Oh, I should show you that. Let's do that. Here. So let's run our program. Remember, I can get the exit status of any program by echoing $? It's 0. Right. If I change the return value, make it 100, recompile the program, and then run the program again, right? Now its exit status is 100, right? So the return value from a main method sets the exit status of the program. I should stop there because it's 19 after the hour, and this is going to start actually talking about using variables and stuff like that in a C program. All right, anybody have any questions for me about programming in C? Any questions about assignment 2? Has anybody looked at it yet?
I had a question about the compiler.
So I'm supposed to have office hours now after class. Does anybody need to talk to me during office hours?
I had one question.
Because I also have a 3-hour departmental meeting starting now. That's going to be lots of fun, let me tell you. Oh, I should probably stop recording before I give commentary on this.